Hey guys, it's Simon and welcome back to another LibGDX video by me. Today we are going to learn how to make simple AIs, because a couple of people out there asked me how we could add something to the dark matter game that we developed in one of the tutorial series. So how we could add there a simple AI maybe with enemies. And other people were asking in the Quilly adventure videos that I also uploaded how I made the character states and the jumping state and so on, and attacking. How would you do that? And today I'm going to teach you exactly that. And what we are going to see is that we develop a tiny little application. Actually, I only explained the important parts of this application. You can download it again from GitHub. And what you will learn is then how you develop a character. So this is our character here, this little guy, and he can run with the arrow button, so we can move left, right, we can jump, we can also fall down. You see at the bottom in the console, so how the different states are then changing. And also one additional thing for, again, simple AI. So this is really for simple ones. If you want to develop complex ones, this is not the approach that I would recommend. But we can also tell now this little priest lady on the left side, so when we are hurt, then after a little delay, she runs then towards us and she will cast then something to heal us. So whenever we are outside of her range and we are hurt, we can tell her that with the I button, which is injured, and then she will run to us and heal us. Okay, so if you are interested to learn that, then stay tuned. So what we are going to use for that little application is that we use GdxAI, so the AI extension from LibGDX, to develop simple AIs. And the pattern that we are going to use, I will link the page here in the video description, is the so-called state pattern. So what is the state pattern? So to explain it a little bit, take this little code here at the bottom. So the goal is to create a hero who can jump. So when you press a button, then the hero should jump. So it's very simple. So input is equal to b, then set the velocity of the y coordinate so that we move upwards or downwards to a certain speed, and set the graphic that we jump. Simple code, sounds good. No, because there is a problem in this code. Can you spot it? The problem is that if you would press B multiple times, you can actually jump multiple times. So we don't prevent, for example, mid-air jumps. Maybe that's what you want in your game, but normally you should only jump once. So how could you solve that? One simple approach would be to add a flag. So when we are not jumping, then set the flag to true and make the jump logic. And when we are done with the jump, then set the flag again back to false. So that would solve that. So the jumping problem is then solved. We can really jump only one time, and that's good. But now, let's say we want to add that also our hero can now duck, that he can go down. Okay, let's introduce that. So that's this little piece of code here. So we have the jump logic from above. If we duck and we are not jumping, then we want to duck. And if we release the duck button, then we want to stand up again. Looks good. But again, there is a problem in that. And the problem is, so we could actually now duck in this case. So we press down, then we press the jump button. So we would then jump with the jump graphic, which could be okay. But then we release the duck button and then we would just stand. So we would be in mid-air and just have the stand animation. And that's, again, a problem. So how to fix it? Again, we could introduce certain flags with is ducking and enhance the code with that flag. And you see, so whenever we want to add something new to our hero, we always need to introduce new flags to come across to fix all those issues that we have. And you can imagine that that is, of course, not a good approach how to solve that. And the solution for that is then actually the so-called state machines. So when you develop a character in an RPG or adventure game or whatever game you want to develop, this article here recommends that you just simply draw up what you want to have. So let's say standing would be the normal state of our character. When you press down, it goes to ducking. When you release down, then it goes back to standing. When you press B, you go to jumping. And you see there is no connection between duck and jump. So when you are in ducking, you cannot go to jumping. That's prevented. So the bug from above can no longer happen. And in addition here also, when you jumping and you press down, then you do a diving attack. And now we want to have a so-called state machine which takes care of that. So the state machine itself can always have only one active state, and depending on what kind of input it receives, it can change to a different state. And with that, we have it a little bit cleaner, that we cannot have 2 or 3 different states in parallel, and also we cannot go from any state to any other state. So there would be a certain logic how this machine works. So these transitions and the states, they make up the so-called state machine. And we don't need to develop that ourselves because, as mentioned before, so we are going to use GdxAI for that. This is also what I used for Quilly Jumper. Or Quilly Adventure, I forgot the final name, I think it's Quilly's Adventure. And there you see on the Wikipedia page, I will also link that in the video description below, they have already a couple of things that you can use for your own games. And the things that we are going to look into today is the state machine, and then also the message handling. So this is then something in advanced that are used with the priest lady that we saw before. So when she, for example, receives a message that the character is hurt, then she does something and changes her state to run towards the target that is hurt, and then she's going to heal it. So this is the thing that you should use for very simple AIs. If it gets more complex, then I would recommend to read up behavior trees, and I think it's called steering behavior if I'm not mistaken. Yeah, this one here for the movement and so on. And this is more complex topics that I only read a little bit about it, so I have no experience with it. So I cannot teach you that one. So the one that I'm going to teach you today are the state machines and the message handling. So for the state machines, a couple of things before we jump into the code. So first of all, let's look into the state interface. So the state describes then, if we take the example from before from the hero, so for example, we have a standing state or a duck state or a jumping state. So that would be one state. And the interface that comes with GdxAI has 4 different methods. The first one is enter. So this is when I'm going to enter a specific state. Then update is as long as I'm in that state. So every frame, for example, the update method gets called. Then we have exit. So when I leave that state, the exit method is called. And then we have onMessage. So this is the combination or the additional thing that I mentioned before with the message handling. So also when you are in a specific state, you can receive so-called telegrams. That's how it's called in GdxAI. A telegram is nothing else than actually any object that you can imagine. So for example, in the example application, it's the injured message or the hurt message that we took damage, and depending on those kind of telegrams, also the state could then change. So those are the 4 methods. We will see that then in more detail than in the code. So coming back to the graphic that we had before, so that would be a state standing. At the beginning, when we enter that, the onEnter method or the enter method will be called. When we leave the state, so when we go to ducking, then exit is called for standing and enter is called for ducking. And as long as we are in that state, the update method is called. And in addition, if there would be a specific message where we are listening to, then also the onMessage method would be called. So this is how you can imagine that. Then, after we know what the state interface is doing, we also need to introduce the state machine interface. So here you can see that. So there are a lot of different methods, and you don't need to know all of them because there are, luckily for us, already implementations available in GdxAI which take over most of the logic for default stuff that you want to have. But let's go through it. So update should be called usually every frame. So in your render loop in LibGDX-AI, the update of every state machine should be then called that you have. Change state is called if you want to move to a new state. Then revert to previous state moves you back to the state that you had before. Initial state is the starting state of the state machine. Then there is also a so-called global state. So normally a state machine in GdxAI comes actually with two states. So there's the normal current state and previous state, let's say. And then in addition, you could have a global state. And I used it, for example, in Quilly Adventure for the characters. So I have a global state which is checking if the character is alive, so if he has enough hit points. And if not, then I move him to the death state, and he's then showing his death animation and gets then removed from the game. So this is the global state to check if the character is even existing or alive, let's say, and can do anything else. And the normal state is then, for example, running, attacking, jumping, and so on. And why did I use here a global state? Because let's go back to the graphic here. So here the character can do all of those things, but actually in all these states there would be an exit condition, let's say. So for example, if the character dies, then he can no longer duck, stand, jump, or dive. And to avoid having all that logic of the alive checks in the different states, I just defined a global state like at the top, let's say, which is over all the other states. And if the character is not alive, then he cannot do anything below. So that's the reason or the logic how I use the global state. Yeah, then you can receive the current state, you can get the global state, you can check if the entity is in a specific state, and it can also handle the message. So these telegrams, as mentioned, if the state machine is listening to a specific telegram, then it can dispatch it to the different entities which are listening to it. And with GdxAI, there are two state machines that you can use. So the default state machine is simply here as above. So it contains always the current state, and whenever you change to another state, then it also remembers the previous state. So again, in this graphic, if we are in standing and we move to ducking, then ducking is the current state and standing is the previous state. And when we call get previous state, we would move back to standing. And if we would call again previous state, we would go back to ducking. So you would, let's say, loop between those two states. So this is the default state implementation. And in addition, there's also a stack state machine. And this one you can imagine like the states are then a stack. So let me open Notepad. So let's say, for example, we are in standing. Now we move to ducking. Then we go back maybe to standing again, and then to jumping. All of that, let's say, in a frame or whatever, or within one game loop. So this would be our stack. So we have then 4 states on our stack. And when we call now previous state, then the stack state machine is just going down the stack. So it will remove jumping, go back to standing. If we now call previous state, it goes back to ducking. And if we now call get previous or go to previous state, it goes back to standing and then to the initial state or empty state. So this is the difference between the stack state machine and the default state machine. The default state machine only remembers, let's say, 2 states, the current one and the previous one. And the stack state machine really remembers a stack of the different states. And you can then go back in the stack correctly if you need that. For our example application, we use the default state machine, not the stack. Okay, and in addition, in this example application, we also use the message handling. There's also a description here, but this one I will show you in the code. I think it's clearer to explain that. For now, you just need to know that you can send any message, so any object that you can imagine with this GdxAI framework to the different state machines or entities, and then they can interact or react on those messages, let's say. And again, in our example, it's the priest who gets the hurt message from the player, and then the priest moves to the player and heals him. And all of that is on GitHub, so there I also will link this link in the video description below. So that contains the entire code that we are now going to check, and there you can then run the example application, play around with it, enhance it, and do whatever you like with that. So it's free to use, do whatever you want. Okay, so within IntelliJ, so we have a normal project with LibGDX again, so we only have the desktop launcher for now. It's not for Android or iOS or whatever. We don't need that, so it's really just a demonstration on the desktop. And the basic framework, or how I set up the things, is the same as I did it in all my other tutorials. So if you watched, for example, the tutorial where we developed dark matter or the Mystic Garden code, then you will already understand the ordering here of the different packages and so on, or the different classes. And what we are going to use is Kotlin again, but of course you can also use Java. And I also use some LibKTX extensions to make it, for me, a little bit cleaner and easier to write the different things. And the application itself is using Ashley, so an entity component system that I also most of the time use for my different games. And we are going to learn how to use now GdxAI in combination with Ashley. So the first things that we are going to need is when you open your build Gradle file of the core project. Let me zoom in a little bit that you see it. You need the implementation, a dependency on the GdxAI library. So it's combat logic GdxAI, and the version, they have then their own versioning, so it's the AI version, and the one from this project is then actually, I think, 1.8 something. Yes, so 1.8.2 is the version that I use in this project for the AI version. So that's the first thing. And then the important parts, and there's not actually a lot that you need to learn. So the first one is we have a component for Ashley. There I have a so-called AI component. Let me zoom in again. So it's the default stuff. So it extends the Ashley component, and it's a poolable component because I use the pooled engine again. And what we need for the state machine that we saw before, so we use a default state machine. Then it has always two types, let's say. So the first one is the owner of the state machine. So what kind of entity is interacting with that state machine. And the second one is what kind of states are you going to have in that state machine. And here we have, we see that then in a moment. So our owner is an entity from Ashley. So that's our game object, which will have a specific state. And the entity state is then just the GdxAI state, but with one or two enhancement methods for Ashley, let's say, that I used. You don't have to use that, but I used it. We see that in a moment. The next thing is then the state time. So how long am I in a specific state? And the third one is the state itself. So what is the current state of our entity? And all of that is within the component. So again, the state machine, the current state, and the state time. And in the reset method, we simply reset everything to the default thing. So if there would be a global state, we set it to null. And if there is an owner, which is normally a specific entity, we also reset that to null. So that's the AI component. Then we also need an AI system, of course. So that one you can find in the system package. And our AI system is then a simple iterating system, which iterates over all entities which have the AI components. And in addition, it's for simplicity, the AI system is also an input adapter, because I react, for example, when I press left or right, the character should move left or right. And for demonstration with how to use messages and so on, this is done by sending a message to the state machine, as we saw it before, and therefore the AI system will just get notified when certain buttons are pressed, and then dispatches this message to the different state machines. So what we have here, so when the system gets added to the engine, then in fact we will set the input processor of the GDX application to our AI system. So with that it can then listen to key events, and it's also an entity listener for the AI component entity. So whenever an entity gets added to the engine and it has an AI component, then also the AI system will get notified. Why? We see that in a moment. So first of all, remove from engine, it's the same thing. It just sets then the input processor to null so that no one is listening anymore. And the remove entity listener is then also called so that the AI system is then not listening to anything anymore. So in our entity edit method, we need to do two things with the component itself. So we need to set the owner of the state machine, which is the entity itself. And we need to set the initial state of the state machine. So that's the state that we have set in the component. That one will be then set as the starting state of our machine. And in addition, we need the so-called message dispatcher. This is the stuff from the message handling system from GdxAI. So there is a message dispatcher which is responsible for sending messages to the different objects, and we are going to use here the singleton instance. So there's a message manager get instance, but we could also create our own message dispatcher. The important part is that this dispatcher needs to be registered to listen to certain events, and for simplicity reasons, for this example, he just listens to all the different messages that we have. So this is treated with a so-called message code. We see that then also in a moment, a little bit later. We have 3 different message codes. Let me show you that one. So those are the 3 message codes that we have in this example application. We react when the key is pressed, when a key is released, and when the character is injured or hurt. I should have called it hurt because for whatever reason I have a problem pronouncing injured correctly. We see in a moment what the message dispatcher is then doing, so why we need this message code and how you can use it. You see that then in a moment. Okay, so this is when the entity gets added. We initialize certain things, and the same thing in entity removed. So when an entity gets removed, then also from the message dispatcher, we need to remove the state machine from that specific entity. And yeah, also we do that for all the different messages again. How that works, so that makes sense then now in a few seconds. Just give me a moment. Okay, then we have the process entity method of our system. Let me also close this one to make it a little bit bigger. So here we don't need to do a lot of things actually. So first of all, we receive the AI component of the entity. Then we need to update the so-called timepiece of GdxAI. This is needed when you want to send a message with a certain delay, and we do that. You see that here already a little bit below. So when we press the I button, as I mentioned before, there we send this character injured message, and we do that with a delay that we also have an example for that. So it's delayed with 2.5 seconds, and to make that delayed message work correctly, we need to update this so-called timepiece of GdxAI. And we do that simply with the delta time that we receive. And I just noticed that this is actually wrong here because, I've spotted a bug now live in this video. So I need to move that actually to the update method, because now the timepiece gets updated for every entity, which is wrong. It should get updated only once. So let me move that out to the update method itself. There it makes more sense. Okay, so it should look like this. So in the update method, so only once a frame we update the timepiece and the message dispatcher, and then this update method is then calling process entity, and for every entity we increase the state time, and we also update the state machine itself. So what that does, we also see that in a moment. So for now, we almost come to the end of that system. We have the key down method because the system is also an input adapter. So when we press the I button, then we just look for any player entity that we find. So in our example project, it's only one. And then we dispatch a message with a delay of 2.5 seconds. The code of the message is the character insert code. And we want to send an extra information. So that can be any object that you want. So some additional information that you want to send with your message. And there we send this character extra info. And the entity that gets inserted is then the player entity that we find here. And very similar, it's with the key buttons. So when a certain key is pressed, then we also dispatch the message, so a key down message, and the extra info what kind of key was pressed is the key code that we get here. And the same with key up. So when we release a certain button, then we dispatch the message. Here it's also an error, I just see that now, so it should be the key up message, and there we have the key up extra information with the key code. So what is that? So that one we need to explain a little bit. So the dispatch message has a lot of different overrides. So this message dispatcher, as I mentioned before, so you can tell him you want to dispatch a certain, I think it was called a telegram. So let's say I call it a message. So you want to dispatch a certain message, and you can do that in a lot of different ways. So you can send out a general message to all the different things which are listening. So in our case, it's the different state machines which are listening. And you just need to provide then the message code. So every message has one unique code. In our example project, we have 3 codes as we saw before. We have the key down, the key up, and the character insert code. Then you could also send that with a certain delay. So those are all those overrides below. So the delay is always in seconds. Then you can send an additional information. So it's called the extra information, which can be any object, as you can see here. What I did here, that you also see here an example. So I used the Silk classes again from Kotlin. So for the key extra info, you need to provide the key code. And there we have a down and a up object for that specific extra information. And for the character extra information, there is a specific type which is called insert. And there you need to provide what kind of entity is insert. Note here that these are objects, so only one specific instance of that message can be available, and that might not be correct for your case. So in case you have, I don't know, multiple character extra information in one frame, you need to take care yourself of the pooling and everything, and to create those instances and release them correctly. For the simplicity of this project or example project, there can always only be one message of that specific type which is sent. Okay, and when we go down here, so there are a couple of other things that we don't use in this example. You can then read it up. You can provide the sender, so who is the entity, let's say, who is sending that specific message. So could be also, for example, for the character insert message here, that would be an example. The sender could be the entity itself, which is heard. So that you know already, okay, I am heard, so I send a message now that I am heard. So everyone who can help me, come to me and help me. So that would be the sender. Then you can also specify a receiver. So if you only want to send a message to one specific receiver, that would also be possible. And the last thing from what I remember is this needs return recipe. So so there you need to, when you send a message, then you also expect that someone is answering your message. And if that's not happening, then I think you can react on that, or an error is thrown or whatever. So I did not use that so far, but I know that there is this additional thing. So in our case, we only use the simplified approaches for now. So we just send a message with a specific code, and it's to all of the things which are listening to that. And we always provide an extra information. And we do one special thing that you also see, this delay. So the character insert message is sent with a delay of 2.5 seconds. And this dispatching of the messages here is then actually happening here in this message dispatcher update. So that message dispatcher contains the logic. How should I send this message? Who is interested in? And for example, is the delay already reached? And then send it out. Okay, and how is now all of that working in the end. So what does that do? So we saw now that we are creating state machines. We have an owner, which is an entity. We go to a specific state. We call now these update methods. But what are these updates methods actually doing? So we don't know that yet. And that is what we are going to look into now. So there's the AI package. And the starting point is the state file. So in the state file, we have an entity state, which implements this state interface that we saw before from GdxAI. So we need to implement the enter, update, exit, and onMessage method. What I do here is that I make it a little bit easier for me to work together with Ashley and the AI component that I have here. So first of all, I have a helper method, so entity AI. This one is returning the AI component of an entity. And in case it's not there, then an error is thrown, because it should not happen that there is an entity in a specific state without an AI component. So that's the safe way, let's say, of accessing that AI component. And we actually need that in almost all the different methods. So in enter, update, exit, and onMessage, we normally always want to have also the AI component, because we need to switch states at one point, and switching states is always done through that AI component. So that's why we override the enter, update, exit, and onMessage method. And what we do, we always get the AI component of the entity. When we enter a specific state, we set the state time to 0, so that we reset it. So that's the starting point of the new state. And from that point on, we increase then the state time. We set the state where we are currently in. And we then call our own enter, update, exit, and onMessage method. And there we simply pass already the AI component, so that we don't need to access it all the time and retrieve it, so that we have that already directly available. So there we have then those 4 overrides, and those are actually the important ones. And all of that together is then this entity state that we saw before. So a default implementation, let's say, of a state. Then we have, just for Kotlin again, to be null safe, so that we never have null states, we have a default entity state, which is just the entity state that we had above with the default implementation. So all methods are doing nothing, and the onMessage is returning false. I did not specify that yet, so why is onMessage returning a Boolean? There is, again, it's similar to the input handling in libGDX. So when someone is receiving a message and you return false, then that means that you did not handle the message successfully, so it needs to be passed on to other things. And if you say true, then you successfully handled the message. So there you can see that here in the return statement. So that's the reason for this Boolean. Good. And then one final thing that I found useful, let me open the example application once more to explain it. So what I had to do in the adventure game that I developed, so Quilly Adventure, there I thought that normally when an entity is in a specific state, it should also have a specific animation, so a specific graphic. And to abstract it a little bit so that I don't need to write the animation code all the time in the different state methods, I abstracted that into a specific class, which I called here the animated state. So it's an entity state, but in addition, it always contains an animation type. So what kind of animation should be played in that state? And you see here, so the player is currently in the idle state, and this is the idle animation that is now played. And this is the idle animation for the priest. And when I press here I, then you see that it changed to run, start cast, cast, and idle. And whenever it goes into one of these states, the animation is changing. It's the same for the attack. So our character can also attack. So pressing A 1 time is a single attack. Pressing A 2 times is a double attack. And pressing A 3 times is a triple attack. And all these different states are always linked to a specific animation. And that's the reason of this animated state. So there you simply pass in, when you define a specific state, what kind of animation should it have. And there is, similar to the AI helper method that we had before, there's also the entity animation helper method, which simply returns the animation component, which again can also not be missing. This should be now entity because it's generic. Let me fix that as well. So this should always be available. When you have an animated state, then there needs to be an entity with an animation component, otherwise something is wrong. And there is one minor thing. So in the enter method of this animation state, we need to set the type of animation in the animation component, so that the animation system and so on is then processing it correctly and switching to the correct animation. And we also need to set the state time of that specific animation also to 0, because we see that also now in a short moment. So in some of the states, I'm then checking, is the animation finished? So for example, when I attack once, is the attack animation done? Then switch to another state. And to have that check working correctly, we need to, of course, start at the beginning of the animation. And beginning of animation means that the state time is 0. Good, so that's our implementation now of the state interface. So again, we have an entity state, so that our state is linked to an Ashley entity, because an Ashley entity is the owner of a state. And we have then in addition our animated state, which also helps us then a little bit with changing the animation of a character or an entity when it goes to a specific state. And now I just want to explain the Mage state, let's say. I think that's enough, because the adventurer state is then very similar and you can check it then on your own in the code base. But let's go through one example. So how would you implement now a real state that should be used by an entity? And there we're going to use the Mage state. So that's the priest who is then moving to the character and is going to heal him. So there again, in the GdxAI Wikipedia, they recommend that you should use an enumeration. I've just preferred the sealed classes of Kotlin, so that's why I use that one here. So for me it's a sealed class with a Mage state, and because it's an animated state, so it's this special animation entity state that we have, so we also need to pass in here the animation type and simply pass it over to the animated state. For the enter, I just wanted to add a log message so that we know when a state is changing. So we do exactly the same code as we saw before in the animated state, but in addition we have now this log message. And now we have in total 4 different states. So we have idle, run, start cast, and cast. And now we see how we could make our state machine work so that it switches between the different states. So in the idle state, we have the Mage idle animation. And when we receive a message, so this is this message dispatching that we saw before. So there we check the extra information of the telegram that we receive. And if it is a character injured message, so that the character is hurt, then we're going to first of all log an information, so who is injured, and that we are going to heal it. Then this is something which is, it's a little bit quick and dirt, let's say. In the real game I would write it a little bit differently, but what that is doing, it simply accesses the entity engine of Ashley, and it adds then the move to components to our Mage, so that it knows where it should move to. So as we saw it before, the Mage is at the left corner and the player in the middle, and with the move to components I can tell a specific entity move towards the entity that I am telling you and stop when you are in a specific range. So what does that mean? Let me open up the application once more. So when we press now I and wait those 2.5 seconds, then the Mage is now moving to the player, and now it's within the range of these 1.25 world units. So this is a world unit is, I think, until there, so 32 pixels in my case, and a little bit more, so the center of the player here. So when I'm within that range, then the move to system stops, let's say, and yeah, that's the purpose of the move to system, that it moves an entity to another entity with a specific range. And yeah, when we reach that, or when we edit this component, then we also change to the state running, because the Mage is then, first of all, it's then running to the player. So this is the change state operation, run. Then we have the run state. What is it doing there? So there I simply check whenever the move to component gets removed, so when it's null, that means that the Mage is within the player range. Then change to the next state, which is start casting, so start the healing process. Then in the start cast state, we now do the check that I mentioned before. So we receive the animation component and we check, is the animation finished? And if yes, so if the start cast animation is done, then really go to the casting state. And there it's also then pretty simple, so nothing special is happening. In the cast state, we just print then the message that the healing is now happening. And again, if the animation is done, we go back to idle. So this is then how you can implement those little states. Again, we have here 4 of them. We have idle, which is the default state. Then we go run to the run state until we reach the player location. Then we go to start casting to play a little bit of an animation for the spell preparation. And then finally the casting, where we would have then the logic that the player gets healed, sound effects are played, and special graphics are played and so on for the healing process. But you can imagine all of that. It's not part of this example application. So again, let's go here to see it once more. So we press I. We have this delay of 2.5 seconds. We go to the run state. We go to start casting. We go to casting, and that's it. So this is how this state swapping and the state machine for our Mage is happening. And that's it. So as mentioned, you can also check out, of course, the adventurer state. So that would be the state of the player itself. There we have a couple of more states. We also go through them very quickly now. So we have we have an idle state again, which is the default state. Then we can go to run and jumping. Before we go to jumping, there's also a start jump, because the animation of the player, he ducks a little bit before he does the jump, and that for me was the start jumping. So there nothing really happens, it's just a small animation that he goes into the ducking mode and then he jumps off. And then there are 3 different attack states and a fall state. And how does that work? So again, in the game we can move with the left and right arrow key. So this is the run state. Let me open the console again. Okay, so here we can see it now. So now we are in idle. Now we switch to run. Then when we press J for jumping, we do start, jump, and jump. When we do nothing, we go back to idle. So for the jumping alone, you can see it goes a little bit down and then jumps. And when we're falling down, then we also go to this fall state. And this is also happening when we are on a cliff and we simply run off the cliff. You can also see that we fall then. So for a brief moment here, we are falling and play the fall animation. And it's very similar to the Mage state, so I won't go through that, but you can check it out here. So there's also then there are just some checks, for example, in the idle state. If the linear velocity of the y coordinate is smaller than 0, then we go to the fall state, because the player is then falling down somewhere. And if x is not equal to 0, then the character is obviously moving somewhere. So we switch then to the run state and so on. Okay, I hope I explained it well enough. It was actually more than I would have expected. Please read up the articles that I will also link, because they contain some very important information and explain it in more detail than I did it now in this video. In this video, I just wanted to explain a little bit how this example project is working and what is the important part for GdxAI. And yeah, I hope it helps you out there and that it's useful to some of you people. Please let me know if you have any questions. I'm happy to help you. And yeah, that's it. Thanks for watching and bye bye.